Well, everybody, welcome to our latest and greatest webinar with Techspray here. And today we're going to be covering pretty much a third in a series of the 3M Novec replacements. And today we're going to be talking about the latest news because it is evolving. It is kind of a fluid situation and what we consider the best available options at this point. Okay, so quick introductions first. Who am I? I'm the moderator, Kevin Pulowski. If you've been through our webinars before, I'm probably pretty familiar. You've probably gotten 5 million emails from me. I'm Marketing Communication Manager over at ITW Techspray. Okay, and with us we have Dr. Saroj Yadav, Marketing Director with ITW. Okay, formerly Product Technology Director. And her contact information is right there. So Saroj is over the marketing for Techspray and Chemtronics. And so she's going to cover from the marketing perspective from what's going on in the marketplace. And then we've got Paul Blair, Product Technology Director, formerly Marketing Director, and formerly a number of other things. And Paul will be covering it from the technology side, from the chemistry side, but really either one are certainly well-versed to cover it from the chemistry side. So on the agenda today, we're going to introduce you guys to Techspray in general. We're going to give you an update on the Novec discontinuation, the options for the replacements, how to future-proof your process, if that's something you need to do. Okay, and we'll talk about what we mean by future-proof, kind of looking at more the long term. Okay, and then along with future-proofing, what's really driving that is the regulatory trade-offs of doing that. The ever-evolving regulatory landscape, we're going to talk through that a bit to some manner of depth, not as deep as we could go, of course. Okay, so let me cover really quick, who are we? Who is Techspray? Okay, Techspray, we're a brand of cleaners and coatings and some other materials from ITW Illinois Toolworks. Okay, that's a conglomerate in Illinois, in Chicago, Illinois. Also, we have a sister brand, Chemtronics. Okay, so everybody on this call handles both Techspray and Chemtronics. And so if you do have a question on a Chemtronics kind of product, we certainly can answer that as well. Our focus today is mostly on Techspray because with the Novec replacements, most of those replacements are in the Techspray line, not the Chemtronics line, although there is a few exceptions. Techspray started in 1968. Okay, so we've been really focused on the industry for a long time. Okay, and that's something I just want to stress, that our experience at this it goes deep. And so to give you a little history, there was stuff called Freon CFC 113A. Great stuff. You could use it in a vapor degreaser, you could use it in an aerosol, you could clean your tie with it, and you could do dry cleaning and use it as a duster. Okay, problem is that it punched a hole in the ozone. We didn't like that. And so moved to CFC 141B. That also affected the ozone. And then AK225 was the next one, and that's gone. Okay, all of this is fairly similar, has some parallels with what we're dealing with today. And the reason I bring that up is we do have the experience to help you through that process. And not only do we have the experience on the chemistry side, but from the application side. And so that's something we can add to the mix. So if you're currently buying from 3M, or maybe through an intermediary, but a 3M material, if you had a technical question, you call 3M, you're going to have a tough time getting help. Where you call us, we have a lab, Paul runs that lab, where not only can we answer your questions, but we can also do some in-house testing and help you solve your issue, whatever issues you're having, or help you through the qualification process. So I just make sure I want to add that. What we do is we blend, okay? So we'll take chemicals from different sources, put them together with what works in a given application, a given requirement. That's what we do. So we develop proprietary blends from existing chemistries, like maybe from 3M, maybe from Chemours, or all these different products we put together to the best solution. And so it requires that we have a deep understanding of what you do. And so that's a value we add as a company.
So as Kevin mentioned, we have a full service lab here for both product development and qualification. And then also we run our factory QC through here as well. We can do small batch prototyping and have basic helpful, I should say, analytical equipment, very useful. We can cover most things. For this type of application, for this discussion, we generally focus on three things: cleanliness, effectiveness. So we would want to get some parts with contamination from a customer's line. We could run through our process with our chemistries to find the how well it works, and if it works, screen for the best product. We have a variety of products, so we can find one that works. We also test material compatibility. And then, once we find something that works, we can also do kind of a process optimization and process recommendations to how best to use their equipment and our stuff. It gives our customers an opportunity to test things before they actually go on their equipment. We have a vapor degreaser, ultrasonic. We also have access to inline batch cleaning system for water-based as well. So we try to do our best to mock up and support our customers' lines.
So now at this point of time, everybody is aware of 3M discontinuing their Novec solvent. Everybody read the letter. I'm sure, whoever is your purchasing department has ingrained this letter forever for the supply chain disruption from 3M. This letter was sent in December 2022, and according to this, they are coming out of any PFAS manufacturing by end of 2025. That means that our PFAS, which are Novec engineered product, straight 7100, 7200, and 7300, and a lot of blended and bulk chemistry in terms of blended products are also part of this discontinuation list. Without going deep into the reasoning why they took this huge stand, they mentioned that that regulatory pressure was building up to come out of these PFAS manufacturing by end of 2025. As obvious, they have discouraged the stockpiling of the material by end user or by distributors. So while this already going on as a constraint to the supply chain, recently they actually announced a force majeure, and they sent it out these letters in October stating that they are stopping the PFAS manufacturing in their Belgium facility, which was because of the regulatory issues, further regulatory issues into the Belgium facility. And they don't know if even they can actually produce any further PFAS into that facility. So it's more and more, pressure on the supply chain from them. And then even if they don't even know, if the POs, open POs or your future orders can be fulfilled by 3M. This means that force majeure actually can make them come out of any contract they may have with their end user, such as defense, aerospace, or medical industry. And it can give them a lawful reason not to fulfill or honor any supply contract. And they cannot even hold the price agreement for their next shipment if they can fulfill it. So if you haven't done any changes to your process or your application after receiving the initial letter from 3M for discontinuation by 2025, this is your last chance or a key indication that you should be proactively looking for a solution or working on another supply or secondary source going forward. securing a supply chain for your process is a key time period for right now. And there are a couple of ways you can do this by working with your finding a new supplier for exact chemical equivalent, or you can have while you're doing working on finding the chemical equivalent supplier, you can also work with the new chemistry or future proof your application by qualifying the new replacement chemistry for the process. So this means that people like us, Chemtronics and Techspray, can help you navigate through the process, and we will in further slides we're gonna give you all the option. You can work with your depending on your application to choose what type of option it can fit into your process or application going forward.
Yeah, and let me just add to just put a fine point on this is so force majeure is basically 3M is taking control of the reins of the supply chain when needed. And so, put this in perspective. If you're a medical equipment assembler and you have it spec'd in, FDA approved, where you have to use Novec 7100 and you can't get it, then your line is down. If you don't have a secondary source, another source for that material. And so say your qualification at best is 3 or 4 months, FDA approval certainly would be out 18 months or something like that, 24 months. So just to put a sense of urgency here that yes, end of 2025 is the phase out. But if you're counting on this as a part of your supply chain where it can be a line down situation, if you can't get it, we really suggest we start that conversation. And as we're going to talk about, either one of these scenarios, we can be an important part of that and work with you to get through this situation.
Okay, so we can kind of quickly start with some of the basics here. What are the Novec solvents? They're solvents for a variety of purposes. The three right off the bat for me is precision cleaning, thermal management, and then also as a carrier solvent. Most of what we're going to talk about here today is going to be about the vapor degreasing. The solvents from a chemical perspective are HFEs, hydrofluoroethers. Get a little illustration on the next slide. But for vapor degreasing, they are either a neat, pure solvent, or they are azeotropic blends. So that, and what that means is the vapor above the boil sump and the material in the boil sump are the same composition. It doesn't change. This gives security over time and safety over time. Azeotropes are very important, and when you find one, they're very valuable. Used very in a wide variety of applications. Some low tech, most high tech. Of course, the most critical applications are expensive products. For medical device manufacturing, aerospace, aviation MRO, oxygen system servicing. These are very critical cleaning applications. Require high purity, high degree of safety, and also a high degree of flammability and purity. Now the neat solvents, the 7100, 72, 7300, they're really more for rinsing and for maybe thermal management. And the reason being is their solvency is really quite weak. The actual solvents themselves are quite weak. They have other virtues we'll talk about a little bit later. But if you blend them with more aggressive cleaning solvents like trans-dichloroethylene and/or alcohols, they do a great job to quench the flammability and then also improve the current regulatory compliance by reducing the VOC because they're exempt, whereas trans and alcohols are both considered VOCs. But the trans and the alcohol are doing the majority of the cleaning. and then the Novecs are there to, and the HFEs, I should say, are there to suppress flammability, lower surface tension, do a few other things. The last bullet point there is a carrier solvent for lubricants, for fluorinated and some siliconized lubricants, for applying lubrication to usually invasive type medical devices, catheters and needles and so on. But it's a non-flammable, it's a great non-flammable way to process and apply these chemistries that are actually very hard to dissolve in other solvents. Okay, so what is a PFAS? I mentioned the Novecs are all HFEs, and PFAS, polyfluoro. I'm sure everyone's heard of this, polyfluoro or perfluoro alkyl substances. The news media have caught on to the PFAS forever chemicals. Every time I see an article in the media, I always look and say, well, which one is it? Which one is it? What kind of PFAS is it? And they seldom do that. They don't want to get into the weeds and get into the chemicals, but it really matters. Definitions really matter for the PFAS. Different regulatory bodies have different definitions. We have the UN and the OECD. We have ECHA in Europe, TSCA and EPA here in the U.S. Certainly, even some states like California and Maine are coming up with their own, and they're all slightly different. Some are the same, some commonalities, some more complicated, some more simple. But they all kind of get around the structures I see on the right side. You're looking for a CF2, a methylene, a fully fluorinated methylene, or a CF3, a fully fluorinated fluoro, and combinations of them. That's poly means more fluoro, and perfluoro means all the hydrogens are replaced with fluorine. So this kind of gives an idea of where they are. But they are different, and not all of them are forever chemicals, and not all of them are harmful. So kind of run down the structures are on the right. The first one is an HFE. As a matter of fact, that's one of the Novec molecules. It's a hydrofluoroether. That oxygen makes it an ether. It has a global warming of 300, or around 300. I think it's 297. A little high, but it's quite a bit more environmentally favorable and lower global warming than the second one, an HFC. That's Virtrel, that next one, which is a hydrofluorocarbon. As you can see, there's no oxygen and really nothing more than carbons and fluorines there, which makes it less susceptible to breakdown in the environment. Lasts about, its global warming potential, I should say, is more than 5 times higher than the Novec product. So structure matters. And then you look at the third one. That is certainly not a forever chemical. That's a HFO, hydrofluoroolefin. And you can see in that one has a double bond in it. And that double bond gives something for the environment to really, to kind of take it apart. And it has a global warming potential of just 1. So you have the top one somewhere in the middle around 300, the next one around 1600, and then the one on the bottom is as low as it really can be at 1 or less. And so it really matters how things perform in the environment, even though these are all actual PFAS. But this opens it up for those of us who are formulators to say, okay, how can we get the good benefits of fluorinated chemistries without the detriment to the environment, without the detriment for toxicity and so on. And so we can the future is actually getting much brighter in terms of the new chemistries that we can do. All of these to some degree suppress flammability. All of them have very low surface tension, which causes the cleaning solvent to spread and penetrate and get into crevices and clean out. The high density also helps them be good cleaners. And for vapor degreasing, it helps move away from other toxic solvents like N-propyl bromide and trichloroethylene and perchloroethylene. Now, the forever chemicals and the PFAS that have gotten the bad rap, that are dangerous, that's the one on the bottom. You can see PFOA. And if some of those articles actually say what the most dangerous and most targeted PFAS are, this is what we're talking about. Perfluorooctanoic acid, sulfonic acids, things like that. These have all of the downsides of PFAS. They're bioaccumulative, they're persistent, they're mobile, and they're toxic. And they truly are forever chemicals. They last for a very long time. You see, it's a big molecule. It's a carbonate molecule. So these are all PFAS, but all very different.
Hey, Paul, I have a question. So that last one, is anyone doing is that what we're talking about? Is there any cleaning being done with that particular product? What's that used in?
Its function is mainly as a surfactant. And so at some point in time, it might have been used for cleaning. It's nothing that's in any of our cleaning chemistries at all. Hasn't been, never has been.
Yeah, so I think, again, to put a little bit of a fine point on this, is we've got some products, for example, the top one is really the Novec material.
Mm-hmm.
It's far from the worst of the bunch, and it's not currently being specifically targeted, is it?
Right.
Okay, so so just to put that in perspective of the gut feel is, oh, we need to get away from PFAS, right now. And there isn't any regulatory driver for this, okay? The driver is 3M is having environmental issues with some of their plants. They want to exit the category, but it's not regulatory bodies saying they have to exit the category or that you have to exit the category. So just, did I state that?
At this point, and I think Saroj will probably get into the more regulations a little later. But there are a couple of things going on. I mean, certainly from a corporate citizenship, there's a lot of companies that are self-regulating and want to get away from the high global warmers. And then there are issues with some of the jurisdictions trying to ban these things, and they're treated differently here versus in Europe. And so are they immediately on the hit list? No. Should we be looking at new things? Yeah, probably, and we certainly are, and we're qualifying new molecules. So yeah, I mean, it's and when we talk about sustainability, secure supply chain, we talked about, well, there's going to be kind of a whipsaw effect in the marketplace with the supply chain on from Novec and PFAS. Sometimes they're going to be available, sometimes they aren't. Sometimes it's going to be too much, sometimes it's going to be too little. It's going to be hard to wind this down. And then there's the environmental sustainability. And then there's also different kind of geopolitical forces that are worth worrying about as well. But
so the urgent thing is first and foremost, get your supply chain locked up in terms of, if you're using 3M Novec, find a replacement, whether it's PFAS or whether it's equivalent or not. That depends on what you require, what's required. But longer term would be possibly exiting some of that.
Sure. And longer term should be just seeking, your adequate or better performance. And we'll get more to this with some of the options, but with a more environmentally sustainable, less less susceptible chemistry.
Gotcha. So got a couple good questions here. Barbara's asking, are regulatory agencies or states distinguishing between good and bad PFAS?
Currently they are not, but we have seen the major regulation from Maine and Minnesota that's like more stringent and more robust than any other states. The mix of stuff has been coming up from other states, learning from these PFAS every day, like, from what type of application they've been used, or is there any alternates actually available for these PFAS? So they're trying to gather as much as they're, as a database for state-wise, and then trying to restrict the use in majority of the cases, which we have seen in commercial type of products, not industrial or manufacturing or professional use.
So with our type of, with what we're talking about, the scope of we're talking about, are we just mainly at more of a reporting phase and a restriction phase with the regulatory body?
For EPA as a federal agency, like, yes, we got these two ruling recently that they're asking to report all the PFAS they have used from 2011 till 22. That any PFAS they have used or import or used in any type of product composition or any kind of concentration, to report that out by in 2025, I believe, to give that data to EPA.
We offer kind of a three-tiered approach. Most of the other companies in this business are not necessarily offering quite as much options. The first one is kind of a chemical equivalent replacement. This keeps operations running, reduces the qualification burden. This is basically trying to reduce the qualification burden to qualifying a new supplier, not qualifying a new process or not qualifying a new chemistry. So if the qualification process is very lengthy, very burdensome, if the expectation is that the qualification process will extend even beyond the termination of Novec availability, this is an option for those kind of customers. Or if they want to make don't want to make just one change now and maybe want to run out of process or make major changes later on, this provides the time for customers to do that. Or again, I mean, right now there's no specific regulatory requirements demanding that this change be made. It's really more a supply. So this is kind of, again, reduces the amount of burden. It's like qualifying a new supplier, not qualifying new chemistry. The next one, the next option is qualifying a new chemistry. And this provides a little bit, this is a longer term solution. In some cases, it can be an indefinitely long solution. But we can look at it as kind of presenting it here as intermediate. But sometimes some of these solutions within this can go on for quite a while. This gives customers opportunities to maybe improve performance, cleaning strength. In some of the products, it gives an opportunity to lower cost. In others, to produce something more environmentally sustainable. To actually look at some of those other chemistries that I referred to earlier, to have a lower global warming potential, and lower toxicity and lower exposure and everything else, that we see as being very sustainable for 10 years or more. That's kind of our expectation. No guarantees, of course, that far out. But this is where we kind of pointing toward. Customers who don't want to go through who want to go through the change process now, but don't ever want to go through it again. This is where we're guiding them to, and it's also a more secure supply chain. Almost every fluorinated solvent that I'm aware of is produced offshore, be it Japan, China, India. But we've supplied manufacturing here in the U.S. and I'm not just compounding like so many other companies that are importing chemistries and compounding them here and calling them made in the U.S. This is actually a full 100% U.S. made product, and so all the geopolitical issues. If anyone on here is part of the supply chain, they'll remember how hard it was to get things during the pandemic. This is a burden that we can alleviate with some of the new chemistries that are coming out. And then the third option is getting away from PFAS altogether. And this would require let me finish one thing about the qualifying new chemistry. This would all be in current equipment. So again, not minimal, little or no capital investment. The last one, changing chemistries would require bigger changes, process changes, capital equipment, new chemistries, whether it be waterborne or waterborne chemistries or different types of vapor degreasing, like a vacuum vapor degreaser and so on. This is higher risk, higher investment, longer term, and also much longer, bigger investment, higher risk. So, okay, so the first one, like I said, direct drop-in replacements. Almost everyone in the industry right now is calling their replacements drop-in. This is truly a drop-in. This is truly a chemical equivalent to, again, reduce that burden and make it more of a qualifying a new supplier as opposed to qualifying new chemistry. These are direct replacements for all the Novecs. And we would be happy to supply analytical test data demonstrating how close these things are to the Novec. Well, I mean, essentially they are the same molecules. GC, which we have right there, is the quickest way to do it, and most efficient, thorough analytical tool we have that we use to check quality and also demonstrate the similarity.
Yeah, I've got a question along this point is, so have we found alternative producers for Novec chemicals? And let me just split this apart a little bit, because a little history lesson. I mean, 3M, comes up with a molecule, they patent a molecule, it's proprietary material, and they trademark it Novec 7100, 7200, whatever it is. Those patents have run out. Okay, so it can be the same molecule can be produced by other suppliers. We can't call it Novec. Novec is a trademark of 3M. But so to answer that question, yes, and that's what we're talking about here. We have other suppliers for that same material that used to be produced by 3M exclusively. It no longer has to be produced exclusively by them. So, can you think of it as sort of, I'm buying a acetone not from supplier X, but instead supplier Y? You possibly could, but with your qualification process of the supplier and of the material coming in. So it's just another way to look at it. So when you're moving away from it, it's not going to be Novec, but it's going to be the same material. Okay, so keeping in mind Novec is the trade name.
I mean, places where this fit. Like I said, long qualification process or very sensitive substrates. Again, carrier solvents for applying particular other chemistries where the substrate has a particular sensitivity to solvents. This is a way to get around that, or to mitigate those kind of risks or concerns.
It's always good to see with the case studies that how we helped our end users in these options. So as Paul mentioned, that we do have a chemical equivalent of the 7100, 72, and 7300. In this case, we were working with this medical implant machining end user, and they were using a straight HFE 7100 as a rinsing reagent in their ultrasonic equipment to remove any metal particulates or cutting fluid at the end of the process. So part of the reason that they were using this, Novec engineering solution because of the sensitive equipment these medical implant machining is using, and then laborious, risky, and cumbersome process of your FDA validation process, which takes forever. So they were looking exactly chemical equivalent, and just because we do have our Precision V3710 as a chemical equivalent, which Paul already showed the GC spectra in previous slide, and they were very quickly approved our product as a secondary source. That what whatever we actually provided with the documentation wise, it's like TDS, COA, and gas chromatography analysis. And we also provided the sample for them to make the decision if that's working on their process or not. So that's like, kind of very positive outcome for having that chemical replacement from our Techspray side of, as a process approval for as a secondary source. It's not just, we are giving them just some sample requirement for their chemical equipment. We are also working with them for their long-term solution. As these are medical device manufacturing end users, so their validation process is long. So right now, having to have that secondary supply source, secured, make them work on the longer term solution, working with partner like us.
Thanks, Saroj. Got a couple of questions. Are you making a replacement contact cleaner? And I can cover that one pretty straightforward. Generally speaking, we're blending the direct replacements, the chemical equivalents as we're calling them. So the same basic chemistry for the critical applications. Generally speaking, contact cleaning, in an aerosol can isn't like class 2, class 3 type of cleaning. And so our focus on those will be in the next category, where we come up with drop-in, kind of replacements that are different chemistry, but you can use the same process. Okay, that's generally our approach for contact cleaning, and we've got a lot of options for contact cleaning, and it's a little more straightforward. Now, of course, if there is, we're working with you in our lab, and it's just you've got a plastic that everything attacks. Yeah, we could certainly do a direct blend that will match what you're using, but we're not currently bringing something that to market just because it doesn't seem necessary, because it's basically a pretty weak cleaning contact cleaner, not necessarily doesn't add much to what we already have in our product line. So that's on the contact cleaning side. Now, Ed, the rocket scientist, husband of Barbara, the cleaning lady, mentions a new chemical working with the same equipment may still require updates to the equipment, for example, seals and the process, different temperatures. So that's a real good point, is the next group. So the ones we just talked about, those you don't have to change a thing because it's a chemical equivalent. It's the same stuff. It's going to boil at the same temperature. It's not going to have any different effect on your seals. We move to the next group. At that point, yeah, you got to look at your boil temperatures and the impact of those different changes, and the potentially compatibility with seals and things of that nature. Okay, so we'll cover that. That's more relevant to the next topic of discussion.
Yeah. So qualifying new chemistry. A lot of this kind of already mentioned a little bit earlier, but the goal is to really continue with current equipment. In this kind of stage, it's the qualification process is a little more burdensome. But capital expense is minimized. Environmental impact can actually be improved. Costs can actually be improved. And then also the supply chain can actually be improved. So this kind of opens up the possibilities for more work, or I mean for other benefits. And then again, this is to minimize minimal burden with maximum benefit. Is what we want to do with this, or what we want to offer with this next group of chemistries. Again, compatibility. As we just pointed out, we are certainly always happy to check compatibility with materials. In our lab, we can do the major screening before you take it online, or before customers start to invest a lot of their time and a lot of their technical and engineering time. And we could bring them into our labs, and then always provide samples at whatever level. on an ongoing basis. I know usually when I'm formulating, the first sample I get from a supplier isn't the last one I beg, because the chemistries go on from one thing to another. But again, this is like I said, it's about maximum benefit with minimum burden.
So let's talk about these alternate chemistry. We do have quite a few options for you to choose depending on your application you're currently dealing with. This is the chart to better understand some of the critical parameter to choose for a particular application. As you see, Precision V is our trademark and Power 4 as well. So Precision V trade name is for safer solvent application, like it's a safer on plastic, sensitive plastic, wherever you have a sensitive component on your product line or equipment. That's where you can choose the Precision V. And in that category, we do have 3810 and 3820 as a part number. 3810 is an engineered product that can also be used as a thermal management or cooling application. So on our more aggressive nature of chemistry, that comes under our Power 4 trade name. And there also we have two different options, 3410 and 3910. And all of these chemistry, either it's Precision V or Power 4, all of them are non-flammable, so can be used in the vapor degreaser safely, and they are very low global warming potential. However, I do want to specify that one of our product, Power 4 3910, is extremely low global warming potential, which is around 2.7. So it's really like, come to the like how HFOs, some of the HFOs are for that type of chemistry. So highly, environmental friendly. And one other advantage this 3910 is that it's manufactured and produced 100% in US. So having this, domestic supply chain where some of the customer who are military, defense, or government contracts who are more relied on these domestically sourced product, then 3910 would be, a best option for as a for application wise. And please reach out to us to get any further information on any of these product, or if you have any question. These are not the only limited chemistry we have in our portfolio. We do have other solution as well in this option 2 category, and we can help you resolve whatever the situation you may have with your current using your current process or equipment. And our R&D is always, looking for new chemistry, which, Paul suggested that we always, looking for new samples and blended product to comply with the regulatory and having to have environmentally friendly products in our portfolio.
Let me just, and also just let me explain something little to segment this a little further. Okay, so if you look at Precision V, if you're doing assemblies that have plastics, rubber seals, gasketing, things of that nature, Precision V is going to be a good path to go to of our trade names here. If you're doing metal cleaning, so machining, cleaning tap oils and filings and things of that nature, Power 4. Now with Power 4, it's going to be more aggressive than you're used to if you're using the Novec cleaners, but it's going to be a lot cheaper, and it's going to be a much stronger cleaner, and you don't have to worry about plastics anyway when you're doing metal cleaning. Now, a common question we have is, are these compatible with metal? Any problem with that? That's not generally an issue with solvents, okay? You get into those kind of issues with water-based chemistries. With solvents, you're really taking a close look at plastics, gaskets, rubber, seals, and things of that nature. And so the more sensitive it is, generally it's going to increase the price, and it's probably going to decrease the solvency, the cleaning strength. So there's some definite trade-offs there.
So the Novec replacements that we're talking about in this presentation aren't just, our Power 4 Precision V Novec replacements aren't just for replacing Novec that's going away in the marketplace. They're also replacing some very toxic chemicals that are still very widely used in the industry, which I find rather surprising. Things that, like N-propyl bromide, trichloroethylene, PERC, methylene chloride. These are all wonderfully strong cleaners, and relatively low cost of purchase, but they're very toxic. So the cost and use comes farther down the line. In terms of danger and exposure to workers, and to customers and to neighbors, of factories into the environment. And so, if anyone is using an N-propyl bromide, TCE, or PERC, or methylene chloride, we'd love to talk to you about trying to offer something much safer. And these are also really are going to go away. The EPA has these on their target list, and I think they might even have sunset dates on these things. So these are things that we can help the customer transition to very quickly. Generally, these aren't really are often not especially critical, but we can help transition them to something much safer, and we kind of overuse this word, much more sustainable in both supply and regulation, and environmental going forward. But this is something we'd like to work on. If anybody out there has already heard one of our presentations before on solvents, we've been trying to get rid of the toxic. We started with the nasty 3, the toxic 3, and some more have been added to it. So we're up to toxic 4. But this is something that's near and dear to our hearts, to produce much safer chemistries.
So yeah, let's talk about another case study which we did with our aviation customer, and they were using 72 DEA in their giant vapor degreaser for cleaning landing gear. Their first approach was to find, the similar, exactly chemical equivalent chemistry, and then work through the process in the meantime for qualifying new chemistry for longer term, as we mentioned in option 2. So as we have our chemical equivalent for 72 DA under Precision V 372 DA, that process went very smooth. We provided sample for this aviation customer, and their requirement was to analyze the samples in-house. So we did that in our lab, and then at the same time we did provide general TDS and COA and full disclosure STSs as well, and gas chromatography, which is a part of full qualification for some of these end users, to make sure that whatever they're getting exactly the same material to use. So that was actually the process wise was not tedious or lengthy as compared to the medical device company. So they took a month to have us approved as a secondary source. However, they did work with us for the alternate chemistry as well, and we did some analysis with the Precision V3410 to help come up to reduce their current cost, and as well as increase their overall cleaning efficiency for a longer term, and just to help them to save some dollars and use the same kind of equipment for their processes.
Yeah, and I would also add to what Saroj said. We also engage in third-party testing to qualify for Boeing. So these have either Boeing D6 or Boeing BSS 7432, as well as Airbus qualifications as well. So for aerospace, metals going into aerospace, we gauge third-party independent tests to verify that for us. Yeah, that's all part of it. So I want to talk a little more, probably buzz through this fairly quickly because this is kind of a lengthy thing. But to really future-proof the cleaning processes, there are new chemistries coming on board all the time that we're looking at. The desk here in my office has about 20 different bottles of different chemistries that we want to get into analysis and into testing here over the next several weeks. But it's going to cause a little bit more of a qualification process. So really gives you an opportunity to start from the bottom up. So how clean does a product have to be? What are the regulatory compliance now and going forward in the future? And to kind of look ahead for some of these things to really future-proof the business. There is definitely a trend towards more environmentally favorable products. And that's really twofold, because the producers of the chemistries are coming out with better chemistries, and there is more of a demand in the marketplace, both from a regulatory perspective and from corporate citizenship and corporate governance and self-regulation as well. And there's fewer and fewer trade-offs. I mean, in our second tier of chemistries, with the trade-offs have been reduced by the benefits that we bring on with the other chemistries. And as we move forward on the chemical side, of course, you're talking to the formulator R&D guys. So I'm always optimistic about what the new products can do. But you can build a process around acceptable cleaning. The downside is that the qualification process will be a bit longer. Investment is probably going to be higher, as well as risk to make these changes. So it's something that shouldn't be entered into lightly, but there certainly could be greater benefits down the line. So I mean, some of the chemistries are somewhat conventional. PFAS-free solvents that are available are hydrocarbons and dolimonene and alcohols and glycol ethers, and if you want to get into biodegradable or bio-based solvents, these are all possible options. However, they don't work in current vapor degreasing systems. This would require investment in, say, a vacuum vapor degreaser. And we're only really getting started in the industry to have a full knowledge of vacuum vapor degreasing. It's an established chemistry, and technology, don't get me wrong, but as more and more people, or as it gets applied to different areas, I think we'll find more and different demands on these type of things. So again, that's risk for a lot of companies to do that, but we certainly have a wide variety of chemistries that we can pull off the shelf here. We can pull out of our formulary as well. So some of the challenges of the PFAS free, it is a when like I said, the PFAS themselves aren't very strong chemistry, but when blended with strong cleaners, they have very, very high solvency, very strong cleaners. Switching to others is going to change that. Is going to change the chemistry. And cleaning efficiency and solvency, compatibility, odor, for sure, flammability for very sure. It is only with currently with toxic chlorinated chemistries or non-toxic fluorinated chemistries that you can really quench flammability and get non-flammable products, or the major switch to water at this point. So really the only two safe options are fluorinated and water for non-flammability. And then regulatory compliance is another issue. Yeah, even the PFAS that we have right now will reduce the number of VOCs. So if we switch back to a solvent, that opens up the issues to HAPs and to VOC and to various other kind of issues that come up, which is the lead into the next slide. Go ahead.
So I know we've talked in length about like those nasty four chemicals, as Paul mentioned, that NPB, TCE, PERC, and methylene chloride has been part of the regulatory stress for years, and they could be phased out in a near future. So choosing them as a option, it would be a huge step backward for anything for your process wise. Another things you have to take into account is the VOC, and the VOC is always regulated by state to state and are industry specific. California is always the leader in coming up with any type of like regulatory changes, and other states follow the suite. The catch is that there are some trade-offs that are associated with these regs. Lower the VOC are some of the higher global warmers. So when you talk about these trade-offs, each regs cannot be looked into in isolation. So I mean, VOC in California made it pretty challenging to use any of the higher VOC product, especially when others, states trying to regulate as well after, California has done their own regulations. The global warmers are like especially the higher global warmers are also under regulatory pressure, and there are not hard restriction, but there are pressure from state to state and country to country on GWP. The basic mantra is like lower is better for the GWP, and and the restriction are coming up for for higher global warmers. For example, Virtual Accept, which is part of these PFAS as well. This product, Virtual Accept, is a good quencher for flammability and has been used into vapor degreasing for years. It's one of the higher global warmer for potential with 1600 as a value. And it's under the stress of the phase out anytime soon with EPA regulation. Recently, as a lot of you guys might be aware of, AIM Act. EPA has been working on the AIM Act for years now for the HFC phase down, and they just confirmed their final ruling in October for HFC phase down, where they suggested that any global warming potential of 150 or lower is acceptable in terms of aerosol cleaner or anything in the propellant phase. So it's like combination of these trade-off that you have to, be worried about for going forward for choosing your chemistry for your application-wise. Another hot topic is PFAS, which are, in media is characterized as a forever chemical, and we haven't seen anything as a restriction wise, but EPA, as I mentioned earlier, that came up with these two new federal articles that the reporting of PFAS from year 2011 to 2022 is required from any manufacturer or importer of these PFAS during those years.
Okay. On this one, I'll go ahead and cover this because I want to this one's just a quick point that I when I put together this diagram wanted to make is we've got users looking for the perfect solution. What's going to cut through all of this that I can use forever? It's going to have zero VOC. I'll be able to flush it down the drain and have no global warming. And what you're describing is water. And we know water is a real popular, it's the most popular solvent out there, but in terms of cleaning off flux or grease or whatever, it just is not going to do the job by itself. So that's what we're talking about. It was, if you're looking for to get in that corner next to water, you've got other issues that come up. So our job is to help you cut through this and find the right solution for you. It's not as matter of just picking one thing out and it's going to be perfect. We've got to find what cuts to the right trade-offs that you can accept within your process. And so that's a value that we can add to help you through that process.
So in another case studies, this one was done for our PCBA assembly end user, and they were using these two cleaners. One was 3M Novec flux remover, and then doing the ultrasonic to manually clean their IPC class 2 assembly. They looked at our hydrocarbon-based Techspray E-line flux remover, which was ruled out due to the flammability and high VOC content. And in the meantime, when they were looking other chemistry, they did send out their PCBA to our lab, and we tried our aqueous-based cleaner SMT 200 for to clean their boards. And the good thing about these SMT 200, it's a PFAS free, and the only thing to look after is that the investment involved to change the process. So this comes under that option 3 category, where the end user actually decided to make that investment on their end to future-proof their processes, and bought the batch cleaner and approved our SMT 200 as an aqueous cleaner, and our field engineer helped them out for the initial setup of the chemistry in their new machine. So all we are saying here, as a Chemtronics and Techspray, we can help out not only finding the right solution, but also can work with the equipment manufacturer if that's the choice you as a company you're to want to future-proof your processes going forward.
All right, so just to recap, I've got a few questions at the end that we'll take a look at, but just want to recap in case we lose anybody. So you don't have to solve this alone, okay? So we covered a lot. It's the first time you've been hit with some of this. Your head might be swimming, but you do have experts here. You've got Dr. Saroj here. You've got Paul here. That their job, my job, is to help you through this. By the way, I'm the chat guy. So if you go to our website, go to the bottom, I'm the Ask the Expert guy. So you send a note, it goes right to my email. So if you have questions, you want to get the conversation started, you can certainly do that, and that'll go right to me, and I can get it to it. Or you can contact them directly. Their contact information is right there. So 3M issued a force majeure notification. What does that mean? It means they may or may not deliver, depending on what situation they have in their own facility. So you're putting your operation in their hands. Need to qualify replacements because at ASAP. Okay, so there is some urgency here. We do offer that direct equivalent as a stopgap, work on option 1, or we can optimize it, lower your cost, add some other benefits, better performance, or your option 2, or we can future-proof your operation. Help you do that would be your option 3. Vapor degreaser is a viable option regardless of the solvent, but beware of the trade-offs. Perfect solutions don't exist. So there's always going to have to be discussions on, okay, what are we trading off? What's the disadvantages, and can we make that work for you? Okay, so we've got a few other questions. Who should we email to ask for copies of your test data on aerospace metals, especially for methylene chloride replacements? Either Paul or Saroj is a good place to start, or I can get you in touch with Bill Martin. Bill Martin is our sales manager in the aerospace market, and so he could definitely be a lot of help. Barbara says you're right that there's no magic bullet. Note that aqueous processes are not always safe and economical. Additive packages can be toxic, especially excessive VOCs. Okay, so her point here is just because it's water doesn't mean you can drink it, right? We've got, so our water-based solutions, it could be 95% water by the time it's diluted, 90% water. Okay. What's the rest of that? Okay, so just because it's water-based doesn't mean it's non-toxic. Absolutely true. There are additives out there that's really commonly added to water that can be harmful as well. And so, pay close attention to that. Work with your suppliers. Certainly, we're upfront about that. And the SMT 200 that we mentioned does not contain highly toxic materials. Another thing that can be really common with water-based chemistries is a higher pH. You'll see a GHS symbol with a hole being eaten into a hand. Okay, and so you have to worry about that in terms of corrosion and things of that nature. So metal compatibility. Okay, so there can be other things. And then waste, she does mention a very good point, waste disposal can be expensive. So do you boil it off and dispose of the leftover sludge, or do you have to dispose of the whole lot of water with contaminant in it? Is something you're going to have to address well ahead of time, as you're qualifying a future-proof process. So that kind of really puts a fine point on what Paul was talking about, was this changing out your process, as any operation engineer will tell you, is a big deal. Okay, so it's going to take time. And so that's not the first one you're going to jump to, right? You need a stopgap, and we can help you with that stopgap and then work alongside you for that longer term solution. Okay, what kind of testing do you do in your qualification testing? That's a good one to end on, Paul. So can you just take us through a typical qualification without getting too deep into it? And I apologize, we're running along, but this is good, meaty stuff. So it's good that we're getting good engagement here. So your typical qualification process for a vapor degreaser application, let's say a class 2 kind of application.
Well, the first question we always ask in any cleaning project is what's the contamination and what is the substrate, and then typically that's where we'll start. And so we can eliminate or include a lot of chemistries even before the parts arrive. So we get parts in depending on whatever cleaning process we want the customer already has in place, cleaning equipment. We can run it through our vapor degreasing. We have a vapor degreaser here in the lab. We can start with, and it's equipped with an ultrasonic unit in the cold sump. So we can do straight vapor. We can do boil sump, cold sump with ultrasonic, and then back into vapor for the rinse. We could run through, if that is inadequate, we can go through multiple steps and actually kind of set the timing in each one of those steps to find out what the optimal least amount of energy, least amount of time, least amount of effort to get the results. And that's generally to check the cleaning. For materials compatibility, we'll bring the materials in, and if the customer has a specific test a protocol that they follow, we can follow that test in terms of immersion at temperature, and then we can measure, weight gain, weight loss, and then dimensional changes to see what effect it has on the part. A lot of the plastics are well known, or the polymers are well known. Polycarbonates and acrylics are always going to be a little more sensitive. Some of the other more engineered materials, engineered plastics and polymers, a little more subtle in terms of their effect. Generally, what we'll do is, say something implantable, we can run through and then screen some and pick the best. But in the end, the final testing is usually through the end user, because they have the biggest responsibility, for their customer and for the regulatory bodies. But yeah, we go back and forth quite a bit. We examine things here and then send them off, and then they examine and they go, what's good, what's bad, and then we proceed from there. Go ahead.
Yeah, and so I've seen the test reports. I mean, test reports generally will offer full details, including recommendations. Mm-hmm. Also, in terms of even into the process, the cleaning process itself, X number of minutes in the sump, X number of minutes in the vapor phase, and also, photos, close up, 40X photos of, the cleaning performance, to show the cleaning performance of a particular component. I think that's pretty common, and you even have some new equipment for that too, right? Some higher resolution equipment to show that. So
sure. We can do things. We can do things like take the FTI or the surface, both before and after cleaning, to demonstrate cleanliness and so on.
Okay, well, very good. Well, everyone, we'll call this a day. We ran over. I appreciate your patience, and I thank our participants here. Paul, Saroj, great job. Appreciate that. And again, any questions at all, guys? You're not in this alone. You have a friend over here in the Atlanta area that we can help you through this process. We do have a field engineers. We do have technical sales people that can get out there, get on site, and help you through this process. So just want to reinforce that. All right. Hey, thanks a lot, everybody.
Hey, thanks.
Thank you.